All right, we're back. We're on page 4 of notes 20 of Calc AB. We're talking about areas of regions bounded by curves. Problems we're going to do here are like calculator necessary because we're going to be talking about like trig functions and then algebraic functions, and the intersections of those you can't really find by hand. Like it's not really possible. So this is going to be like a how to best use your calculator to solve these problems type of thing. And I have a couple of suggestions, one of which is storing values. So like you want to store as many values as you can. So let's see if we can do this. So we want, I think I can sketch this by hand, but like, I mean, there's no real purpose because we're just going to use a calculator anyway, but X is going to be greater than 0. So I'm just going to like sketch sign, and then I'm going to put 0.3x. So 0.3x I think is kind of like this. One thing I don't really know by hand is like, is the slope of 0.3x so small that it might actually intersect sine again, like over here. I tend to think that's not the case because of the way the problem is written. But also sometimes I don't think these things through when I write the problems. So like maybe it does. All right, so we need to find the intersection point here. They definitely intersect at 0. We're gonna need to find that and then use the calculator to just do it. So let's do the calculator thing, and I'm gonna come back and show you how you should write out your work for something like this, because it's like you're gonna need to use the calculator. But let's see. So I'm gonna start with a graph, I think. So sine of x and then 0.3x. Okay, so not so extreme that it would intersect again. What would that need to be? I don't really know. Like 0.05x. There you go. Oof, that would be an annoying problem. But 0.3x, not so much. All right, let's find, I think that you want to get a good window. So I'm going to zoom box around this. This is like all we care about. Let's do menu 814. So you can use solve for sure. I find it a little more annoying actually to use solve on these because you need to like store the value. Storing the value on the graph page is actually, I think, easier when there's multiple values. So here I'm going to press control and menu. So it's control, this button over here, menu, this button. I can't do it on the emulator for some reason, but control menu, store. I'm going to store that as, I'm going to store it as XC. So if there's no other value, well, I mean, B makes sense too, because it's like the upper bound of the integral. So I'm gonna use B, okay. And so what I'm gonna do, and I'm gonna write it down right now on the notes, is I'm gonna say, let B equal 2.35644. I like to use as many decimals as the calculator is gonna show me. Calculator actually has more decimals than what I just wrote. Let's go to the calculator page. So this is me not trusting the bounded area thing, because I just don't. But I want to now do, so just type B or press var and then choose option B. And then arrow up and press enter. And you can see it's storing a lot of decimals, like way more than it's showing you. So I need to do the integral from 0 to B of the top curve is sine of x, which I think was f1 of x, and then the bottom curve was f2 of x. Or you can type them in, it doesn't really matter. It depends. This is clearly faster, and using the vars key also way faster, but up to you if you want to do that. So I'm going to handwrite this at the same time. So 0 to B of, so I didn't name the function, so I'm going to write sine of x minus 0.3x dx. And then say it's approximately 0.874. 3 decimal places. It's got to be accurate to 3 decimals. They use this weird policy where like they expect you to store all the values, but then write them to 3. So sometimes you get inconsistent answers if you only use the 3 decimals for like your bounds. I don't know. I don't like that policy, but nothing we can really do about it. 2 things. So one, I'm going to go back to the graph page. Notice that I got all of these decimals. You may not have gotten all these decimals. If you didn't get them, press menu, press 9, and in display digits, make your display digits float 6. And if it's an option, which doesn't really seem to be an option anymore, make it the default for like everything. So I'm just gonna press OK, and I think it'll be the default now for everything. You want that so that you can see enough digits The other thing is, let's see if we can do it. Menu 6, option 8 is bounded area. Lower bound is 0. And I'm going to try to just type in B. What is this? What? All right, hold on. Menu 6, 8, lower bound 0. Lower bound. Why would you be asking me the lower bound again? Oh, it switches to upper bound when you like. Ugh. I'm just going to type B and see what happens. Nope. I'm going to type 0 plus B and see what happens. Okay, so I think that's like a weird hack that like maybe works, but like shouldn't be necessary. Like when it won't do the upper bound that you want, if you type 0 plus the upper bound that you want, it always seems to work. And we get the same value, but I thought that was harder to do than setting up the integral. But either way, good deal. Let's see what the next question is. I think we can knock out potentially, oh, I don't really know what's on these pages. I was gonna say like maybe we could do all 4 of these and then maybe come back and do those. Maybe do 3 of these, who knows? All right, what does this look like? This one, again, there's no real reason to do this by hand, but I'm going to. So cosine is like this. And then 0.4x squared is like this. So we'll get this and this. It's going to be symmetric. Well, not according to my picture, but according to the math, it's going to be a symmetric region. So we can do 2 times the integral from 0 to a particular value. All right, we need a calculator though. So here we go. Back to the calculator. All right, so what did we learn last time? So let's start a new problem and graph page. Cosine of x, and then 0.4x squared. All right, we talked about getting a good window, so let's do that. Zoom box is definitely like your best friend on that. So we get a good window. We're gonna do menu 814 to get my intersections. Menu 813 if you have the original CX, or like maybe anything older than that. It is symmetric, so like we could go 0 to the intersection point and then just double it. It's up to you. I'm going to store these, so I'm going to do control menu. I'm going to store this as A because it's the lower bound, and I'm going to store this as B. Now when I'm handwriting it, I could just do like store A and then do like the negative of A, but I'm not going to do that. So on my notes, I'm writing let A equal negative 1.08273, B equal 1.08273, and then I'm going to write the integral from A to B. So once you've said let whatever, you can just use it. You don't have to write the numbers again, which I think is like awesome. All right, the cosine graph is on top. The parabola thing is on the bottom. So let's go to the calculator page and get the answer. I don't particularly love using area bounded by curves. I'm going to try it. Let's see. Lower bound. A. Can't do it. What if I do 0 plus A? For some reason you can. 0 plus B is the upper bound. So I think we're going to get 1.428. But it's like, I don't know. So 1.428. I just don't like it. I don't like it. I don't like that I have to do like the extra weird 0 thing. I don't like any part of it. I prefer this. I like to look at my integral. Like this is what I've written on paper. So I'm going to do A to B, and then I'm going to do cosine of x minus 0.4x squared dx, and we get, you get the same answer. You also, by the way, could have done, so there's one, sometimes when I'm being really lazy, I don't bother to think about it. I'm just like f1 of x minus f2 of x, and if I get a positive, I'm like, good job me. If I get a negative, so if I do f2 minus f1, I just like mess up top and bottom, you just get the negative of the correct answer. So like, you know on paper what you're gonna write. So like get it right, but if you get it wrong, it's pretty forgiving, I would say. All right, let's see. I think we're kind of rolling on these. The next one, I'm gonna just jump into here. So I'm gonna start a new problem, graph page. So I'm doing C, 3 minus 2 cosine of x, because I don't think this is gonna be symmetric. Maybe it is, 2 over 1 plus x squared. I think it will be. We want to get a good window. Zoom box. This is key. Like you gotta just do enough of them where you have your method and your method is like good to go. Menu 8, 1, 4. You can knock them out quickly. Are these just symmetric? They are. All right, I'm going to store it. So that's control menu, option 5 stores A. Control menu, option 5 stores B. On paper, on your paper, you're going to write let A equal negative 0.649256 and B equals 0.649256. Do it. Be organized. People will love you for it. And then we're going to do the integral from A to B of, what's the top curve here? The top curve is the not cosine thing. So it's going to be the quantity 2 over 1 plus x squared minus just, oh, that is not just cosine. The quantity 3 minus 2 cosine of x, and then dx. You gotta be really careful with your parentheses on that, which is why it's actually safer to use the stored functions. So here, if you're not sure which is which, just like ask your calculator. Okay, so that's the cosine thing. So I'm gonna do the integral from A to B of not that, so f2 of x minus f1 of x dx. So 0.826. It's approximately 0.826. So what you could have done that would have looked cleaner, let me go back to the notes. So it looks cleaner and it is safer because of distributing negative signs. You don't want to get the integrand wrong. And like, this felt very risky while I was writing this integrand. I'm actually going to move some stuff here. Right, so what I could have done is I could have said, let f of x equal 3 minus 2 cosine of x. G of x equal 2 over 1 plus x squared. Using these let statements, the person reading your work now reads the let statements and is like, okay, so I recognize that this is the correct integral. And then you can do this. And this is better. This is a superior work, right? If you do this and you do this, this is what I'm looking for. This is my dream work right here. Now the other one's okay and it gets the right answer, but like, it's not my dream work. All right, let's see. This one I think is not going to be symmetric. I'm hankering for a non-symmetric region so that we can like talk about it. Not even talk, it's going to be exactly the same. New problem, graph. Your goal in life is to get to the point where all of these are the same. And once they're all the same, you've mathematically ascended. You don't have to think anymore. Ooh, not symmetric. All right, we want a good window. Zoom box around your interesting window. We want to find intersections, menu 814 or menu 813, depending. We want to store these. So control menu, store as A. Control menu, store as B. All right, then I'm going to add a calculator page. See, it's like second nature. You're trying to get it to be second nature. What's on top? It had to be, I feel like it had to be the sine curve. Yeah, the sine thing is on top. Okay, so I'm going to do the integral from A to B of the sine thing, which I think I put in f2 of x minus f1 of x dx, get 2.543. All right, so I didn't write anything. So now what I'm going to do is I will switch back to the notes and I'll show you what I'm writing the entire time. Maybe I'll copy the graph a little bit. I don't know. Like on a calculator problem, I don't know that I would copy the graph. I should probably copy the graph. All right, so we have like, but what does it look like? I don't know. That's not even a marker. Right, whatever. I'm gonna say let f of x equal 2 sine of x. G of x is x squared minus 1. A. So what did I write for A? A is going to be negative 0.423028. B is 1.72517. So we did the integral from A to B of the top curve, which is the sine thing, minus the bottom curve, which is the other thing, dx. We got approximately 2.543. 2.543. This is what I expect your work to look like. This is good work right here. If you're doing work that looks like this, no complaints. No one could complain. All right. So that's it. I'm going to stop this video here, come back in the next one, do the rest of this page, and I will see you there.